it's trivial almost.
Okay.
Okay, go on, I'll go through it. So just this thing at the bottom, so here we had two consumers. One type 1 consumer, one type 2 consumer. And the exercise said, well, what happens if you've got n type 1 consumers and n type 2 consumers? Okay, then the firm's profits are, well, from selling to the... Okay, so each type 1 consumer has demand P1 and Q1. Each type 2 consumer has demand P2 and Q2. So what's total quantity going to be?
N Q1 and N
Yeah, exactly.
Q2.
Yeah, so capital Q, you see that, is N Q1 plus M Q2. And profits, well, profits, they sell n copies to the low type, to type 1 I mean. You know, so it's like selling a total of n times Q1 units at the price of P1. Plus MPQ2, Q2 minus C of capital Q, which is NQ1 plus Q2. So that's what profit says. So again, you know, rather than the firm choosing the total quantity sold to one type, we're modelling the firm is choosing the quantity sold to each individual of each type. Okay. You know, it's equivalent to choosing total quantities, but here this firm is choosing how many units to sell to each individual of type 1, how many units to sell to each individual of type 2. And then the first order condition is going to be pretty standard. So it's almost exactly the same as what we had before, but now we've just got n copies of this thing. So we get n P1 dashed Q1 times Q1 plus n P1 Q1. And that's from that term. Then from the next term we get m. We get m P2 dashed Q2 plus m P2 Q2. And then we get the marginal cost term. What am I doing? No, sorry. We just did signal Q. I'm half asleep. We're just differentiating with respect to Q1. Sorry. And the marginal cost term is minus C dash n Q1 plus m Q2 times n. Because, so the derivative of the inside here is n. Okay, so we get an n on the end. Sorry about the mess. So then, well, you know, it's kind of, if we then divide through by n, okay, the n's cancel out. So you get marginal revenue from selling to one type of consumer is equal to marginal cost. That's right. I missed an n. Makes sense, doesn't it? Good. That's all. Yeah, so yeah, the firm is equating the marginal revenue from selling to each consumer individually with the marginal cost of selling to that consumer individually. That's the way to think about it. Okay, so this question well, it's a bit messy, isn't it? Does someone have notes from the lecture so we can rather than going through everything we did in the lecture again, can someone tell us what answer we got for profits? Because it ought to just be a matter of plugging things in. So this question we had. I'll just remind you what the thing was in the exercise. We had two types of consumers. High types had demand 1 minus p. Low types had demand a minus p. Firm has a choice of well, we're investigating how the decisions differ when the firm has the option of doing discrimination on them. Okay, if a firm can price discriminate, it's going to sell a different price to both types of consumers. So effectively, it's acting as two different monopolists. Okay, so it maximises profits from selling to the first type, it maximises profits from selling to the second type, and the two problems are independent under discrimination. Okay, so under discrimination it says P1 is a half selling to the high types, and P2 is A over 2 selling to the low types. Okay, so the total output was the sum of these quantities of 1 plus A over 2. And what we're interested in? Yeah, okay, so whereas without discrimination, okay, so with discrimination the firm can see what type of consumer you can charge you a different price depending on what type of consumer you are. If the firm can't see what type of consumer you are, or isn't allowed to do it by law, then they have to decide whether or not they want to set a price that's so high that the low type consumers aren't going to buy it at all, okay, in which case they're just going to maximise profits from selling to the high type, or whether they're going to choose a price at which both high and low types are prepared to buy the good. And what we found in the lecture was that if they sold to both markets, then profits were this. Okay, so we've got an expression there for profits, and we've got an expression there for price. So we can just plug in. So we have that pi is 2p 1 plus a over 2 minus p. Okay, and we know that p is 1 plus a over 4. So this is if the firm decides to sell to both types of consumers. So plugging in, we have that pi is 1 plus a over 2 times 1 plus a over 2 minus 1 plus a over 4 is also 1 plus a over 2, right? Okay, so this is 1 plus a squared over 4. So if the firm sells to both types, that's the profit they make. But they always have the option of just selling to the high type. Okay, if they just sell to the high type, their profits are just P times 1 minus P, price times quantity, because we're no marginal cost here. So their profits are always equal to a half. No, a quarter. Price is a half, profits are a quarter. Okay. So we want to compare whether this thing is bigger than or smaller than a quarter. Okay, so this is a quadratic. Well, when A is very large, okay, when A is large, this is going to infinity. As A gets bigger and bigger, well, A can only go to 1. If A is equal to 1, then this is 2 squared, which is 4 divided by 4, so total profits are 1. Okay. Have I made a mistake?
Isn't 1 plus a over 2 minus 1 plus a over 4 just 1 plus a over 4?
Yes. Yes. So what happens with them? Obviously. Okay, so this is 1 plus a over 8, yeah. Thank you. Okay, so we want to know. Okay, this makes a lot more sense now. So when A is 1, it's like the low type consumers are the same as the high type consumers. So you get a quarter from selling to the low type consumers, quarter from selling to the high type consumers, so your total profit is a half. Okay, and when A is 1, this is 2 squared, which is 4 divided by 8, which is a half. Okay, so this is right now, thank you. So when A is 1, you certainly want to sell to both types of consumers. When A is 0, well, this is 1 squared, which is 1 divided by 8, which is less than a quarter. You certainly only want to sell to one type of consumer, to the high type. Okay, so there's going to be some value of A in the middle, at which you're just indifferent between selling to one type or both types. So let's just set the two things to be equal. It's easier than manipulating inequalities. So what happens when that is true? What is the magic value of A that will make the firm just indifferent between selling to both types or just selling to one type? Well, times both sides by 8. This says that 1 plus A squared is equal to 2. So 1 plus A is equal to the square root of 2. So A is equal to square root of 2 minus 1. Okay? So if A is bigger than this value, the firm wants to sell to both types. If A is less than that value, the firm wants to sell to only one type. You know, if you want to do it slightly more formally, well, you can kind of reverse the argument. Well, suppose that A is less than square root 2 minus 1. Well, then 1 plus A is less than square root 2. So then 1 plus A squared must be less than 2, because you know A is positive, okay, for one of them, many things. So 1 plus A squared over 8 is less than a quarter. Okay, it's just running the argument in reverse, basically, with an inequality stuck in there now. So if A is less than square root 2 minus 1, then profits from selling to both markets are less than profits to selling to only one market. Okay, so if that's true, then the firm only wants to sell to the high type. Are there any exercises here? Here we have some. So, well, before we go on, there's something I wanted to show you, which I kind of forgot about the other day. So remember we were looking at, a few weeks ago we were looking at repeated games. And remember I was saying that in these infinitely repeated games, you know, almost anything could go. There are lots and lots of equilibria. These ones would make lots of profits and ones would make hardly any profits at all. It's still a topic for bugs, some game theorists. And this paper only just came out. You know, I'm sure there are other similar papers, but I just wanted to show you that you're doing something that's not that far from what people are interested in these days. So these guys look at an infinitely repeated game, and they look at the concept of justifiable punishment. So they say a punishment is only justifiable if, so someone deviates, you're only justified in punishing that person if their deviation has actually made you worse off. Okay, you don't punish people who actually make you better off. And if you have that small extra restriction, then it turns out that the only equilibria is then the Pareto dominant one, the you know, the maximum profit one. Have I got that right? So, punishment is justifiable if either the deviation is bad to the other player, okay, so the person deviating has hurt you, or the continuation itself is good to you. Yeah, I've simplified things a little bit. But so if you restrict equilibria to these ones which have justifiable punishments, you don't punish people for making you better off, then in fact only the Pareto dominant one survives. Where was it published? Games in Economic Behaviour. Good journal. It's reasonable work. It's not really my field. Who's teaching you games? Alex.
Yeah.
Yeah. Okay, 5. So for these few exercises from lecture 5, we looked at some of these, but not all of them, I think, because we hadn't done enough last week. Did we look at 3 last week? 3 looks quite easy, actually.
We might have only done 13.5.
Oh, really? Okay, has anyone tried any of these? Is anyone bothering to do exercises? The point of this class is to go over the exercises that you've already done. It's basically just, 6 I said was tricky. Let's start with 6 because maybe it's more interesting. So this seems to be a durable good exercise. Did anyone try it? Did you try it? I don't know. So, okay, so we've got 2 periods. So this is going to be a durable good question. So one consumer wants to buy a TV in period 1. So he gets $100 of value per period of watching TV. But so some consumers are born in period 1, some consumers aren't born until period 2. But the ones born in period 2 are prepared to pay a maximum of $50. Okay, so it's like, maybe born is the wrong word, maybe there's a load of immigration or something. Or these are students, that's a good one. It could be during start of the summer holidays, you know, around many people around, and then September all these students come. Suddenly people value TV a lot more. Not that you guys ever watch TV. Okay, so there's a monopolist selling TV sets. TV sets are durable. Production is costless. Okay, so we've got to calculate the prices. The monopoly charges TV sets in period 1 and 2. Okay, so, well, period 2 sounds easy. So what price are they going to charge in period 2? What price would they want to charge in period 2? So remember when you start with these games, we always start at the last period and work backwards. So that's why we start at period 2. Well, maybe it's not obvious, but how are we going to work it out? 50 looks... Yeah, so 50 is a good start, and I expect that's probably the answer. So if they charge 50 in period 2, they're selling to everyone. Okay, so if they charge a price of 50, so we can assume we're just 2 consumers. Okay, so one consumer period 1, one consumer period 2. So if they charge a price of 50, then in the second period, they're at least getting the 50 from selling to the low value consumer, and if the high value consumer hadn't bought in the first period, they're going to get that 50 as well. So clear, you know, if we were at 10 high value consumers, if the price was, you know, I don't know what the price is in the first period, but whatever the price is, either all of those consumers or none of them are going to buy in the first period, right? So you don't gain anything by thinking for 10 consumers or 20, you might as well just have one. Because either all of them or none of them are going to buy. Okay, it's not like in the example we went through in the lecture where we had a linear demand curve, okay, and then some fraction of the consumers were buying. Here, over all of them are going to buy what none of them are going to buy. Would they ever want to charge a price above 50? So suppose the high value consumer hadn't bought in the first period.
I don't think it matters if they buy in the first period because it says a maximum price of 100 per period of TV usage.
Yeah, that's their valuation.
So in each period, or do they only pay once?
So they pay once, but they get $100 per period of value.
Okay.
So the high type consumer values it at 200 for TV. The low type consumer values it at 50. Well, suppose they set, if they weren't going to sell to the low type consumer, they'd want to, in the second period, they'd want to make as much money from the high type consumer. Okay, the high type consumer in the second period is prepared to pay $100 if they don't have a TV yet. So they've got a choice of selling to both the low type and the high type at a price of $50, or just the high type at a price of $100. So they're actually different between the two. Go on.
Does that they've got two consumers in the second period and only one in the first period of the question?
Two consumers. Oh yeah, you're right. That changes it. Thank you. Always read the question. That's a useful lesson. So there's only one. So there are three consumers in total in that. Okay, I misunderstood. So in that case, if they set a price of 50 in the second period, and the high-tech consumer hasn't bought in the first period, then they make a total of 150. If they set a price of 100 and the high-type consumer hasn't bought in the first period, then they make a price to a value of 100. Okay, so in the second period, they definitely want to set a price of 50. Okay, if the high-type consumer has bought in the first period, then they have a choice of getting 100 or 0. If the high-type consumer's already bought, they're not buying again. Okay, so in either case, whether or not the high-type consumer bought in the first period, in the second period they want to set a price of 50. Okay, so if they're setting a price of 50 in period 2, when would the high-type consumers like to buy?
In period 1, wouldn't the high type be willing to pay 200? Because
They're going to get it for 2 periods for 100 each.
Yeah,
they wouldn't.
Why?
Because when they buy it, if they pay £200, then overall they'll have 0 profit from it.
Yeah.
If they bought in the second period at 50, they'd gain 50 economic profit.
Yeah. So the indifference level is if they sell 150 in the first period,
Yeah.
50 in the
Good.
second.
Good. Okay, so 150 is the most they can charge for in the first period. Okay, so the monopolist is going to set a price, just a tiny bit below that in order to persuade high types to buy in the first period rather than the second. So the high types get a surplus of 50. Yeah, that works. Okay, so what was the question? Calculate the prices for monopoly charges for TV sets in period 1 and 2. So we've done that, 150 and 50. Answer the previous question, assuming that in the first period, a consumer who lives 2 periods is willing to pay no more than $20 per period of TV usage. Go on.
So in the previous one it says he's only willing to pay a maximum of 100 in period 1, so how can you buy a TV for 150 in period 1?
Did I misunderstand the question?
You said he's only willing to pay a maximum of 100.
It was per
100
period.
per period.
Period.
So if
TV usage.
he's paying 100 in period 1.
But
So he'd
Then
pay
he's
the
gonna
100
live
for the
2
use of
periods.
period 1 and 50 for the use of period 2,
I
all
see.
in period 1.
Yeah.
Okay, yeah, sorry, it's misunderstood.
Yeah.
This is not a nice question.
Huh?
Not a nice question.
Okay, so if the consumer who lived 2 periods was only willing to pay $20, then that's going to change things, right? In the second period, okay, suppose that the consumer hasn't, well maybe it's not going to change things. Suppose that the consumer hasn't bought anything in the first period, okay, then in the second period, what price is the firm going to want to set?
If he's not bought anything in the first period, then the price they can set is going to be
20.
50, because there's two consumers in period 2 who will both pay 50, which is better than having the 3 consumers paying 20.
Well, it's that price of, will you increase price in second period?
The issue with that is if the consumers bought TV in the first period,
And sell
they
it.
could then sell it in the
Yeah.
second period.
Oh, okay.
Because they said it's durable, didn't they?
Yeah. I think you may be going beyond the question. I'm assuming there's a resale market.
If there is a resale market, then they'd have to set the price at 50 in both periods to prevent resale.
That's the one we buy it.
Yeah, but they,
They couldn't prevent resale, could
yeah, they could, because the
But
others,
isn't it?
no, it's just
the
not-
first guy wouldn't buy it if it was
Yeah.
50, because he doesn't value it
But
at
he's
50.
only willing to pay £20 per period.
Okay, so let's solve the
It's
problem
game
first
theory,
without
so zero
resale and then
marginal
with resale.
So we get zero profit.
Okay,
after
so
15 sells it.
So without resale, yeah, but in the second period, the monopolist has a choice between getting 100 by selling to the two period 2 consumers, or 60 by selling to all 3 consumers. Okay, so they always prefer to get 100. Okay, so and if so that's if a high type consumer hasn't bought in the first period. If a high type consumer has bought in the first period, then it's 100 versus 0. Okay, so in either case they want to set a price of 50 in the second period. So then in the first period, yeah, no, 20.
Set a price of 40.
40, because you might as well get
Because you've
£1
got
in the
20
first
both
period,
periods.
so it's going to be there for 2 and then put up the prices for the new people.
But then he could sell his TV for like
So without-
49.
So without
And then
resale,
profit.
Oh, without
surely
resale,
no
okay.
Then you could have
40.
40 and then 50.
Yeah.
50.
So do these second period consumers, do they not exist until the second period? They
They're
don't.
not
They don't
born.
need to sell it before.
Okay, so they can't buy early.
spend if they have conscience.
This is a very advanced
I
world
assume
where
that
as soon as
he
you're born,
sells-
you
he
have
sells
an
TV
sets on
infinite
Europe.
mouth. It's
Yeah.
Like robots rather than humans.
So your argument was
T-Rex won't pay.
so why was it 40? Tell me
Because he's
again.
willing to, it's worth 20 for each period.
Oh yeah, of course. Yeah, okay, that makes sense. Okay, with resale,
It has to be above 40 in the first period. So it has to be 50 in the first period,
yeah,
and it can be 50 in the second period.
well it can be 40. Can't it? You just have to stop.
No,
Is it still-
because you
Because
could
Then
sell
you
it
sell it
as
for the
is.
profit.
It's
I know,
worth
but
40 to him if he
If
sells
it was 41, the first guy just wouldn't buy it.
no, he'd buy it.
He'd buy it.
No, it's still
Buy
buy
it
and
and then
sell.
sell it
You're
and
right.
sell it.
You're right. Yeah, buy and sell it. Okay.
I think actually it has to be higher than 50.
Hmm?
Yeah.
Yeah,
It has to be
it would.
70.
So the second period.
No, it
people
wouldn't have to be
were willing
70,
to pay
50 is
50.
fine because he makes
No,
zero
no, it's
profit.
alright.
It has to be
70.
70.
It's alright. 70
Because he gets his 20 from consuming it in
Oh, in the first
period.
period.
And then he
plus
sells the
the
second hand
50.
TV in
Yeah.
the next period.
But he sells it to
Okay.
only one of them, and that could bid up to their maximum,
Yeah.
But that maximum
Which is 50.
which is 50.
Yeah.
Yeah.
Yeah. Okay. Let's go to 70. Okay, that's quite good.
Oh, he wouldn't buy one because he's got more. No, but he'd resell it, but he wouldn't buy it. Yeah. Yeah, but the value turns more. You can like buy a tennis membership. 40? With resale. Oh, but the maximum is 40 anyway. So it would be 40, 40 or 40. No, for the not just to make it 40, 40.
What did we just...
Yeah, but you don't want
So
to
if,
make
with
profit.
resale,
With resale, what's the price of the
17
first?
70.
70 because of the 20 and the 50.
Yeah.
Yeah.
Okay. And then it's 50 in the second round.
Yeah.
Yes.
So we did no, we didn't do that one.
Yeah, it was only just a video.
Did we 13.20?
So
Who's coming
we'll
up
pass
tonight?
those.
But anyway, the point is that
Which friend is coming up tonight?
in the next period we
He's
sell
from
for 50
Lancaster.
to 70 units worth.
He's down here for
Oh,
interview.
yeah.
Can we look at him actually in placement?
Oh, Andy.
Oh, yeah.
I know Andy.
Andy's
I didn't know you know.
Yeah.
Of course I know Andy. I was at your house party. Cat invited me.
Oh, that way you sell them.
Yes.
And the people buy it.
Okay,
No,
well
we
maybe we
went
should
to
do
women.
the scoring exercises.
So we went to women.
Yeah, so
Um,
if they say 70, you get his use
Oh,
of
yeah.
So let's see if we can get through them quickly. So the first one, monopolist is price discriminating between two markets, linear demand curves. This looks a bit like what we just did actually. 2 minus P, 4 minus P. No resale. Marginal cost of 1. Okay, so let me just write it down. So Q1 is 2 minus P1. Q2 is 4 minus P2. Calculate the profit maximizing output level of the monopoly sales in each market. Calculate the price charged in each market. Okay, well, the two markets are independent. You know, the set marginal cost is constant, so the monopolist is just going to charge, treat each market as separately. So just like solving two monopoly problems, basically, in this case. So profit from selling in the first market is going to be price minus cost times quantity, so P1 minus 1 times 2 minus P1. Without doing any calculus, what's the optimum price? Come on, you should be a wizard at doing these things without calculus. Pardon? What are the zeros of this function? When a profit's 0?
It's 1 and 2.
2 and
1
2.
and 1. Yeah, 1 and 2.
So
Yeah.
1.5.
Yeah. Okay. So
Oh.
P1 is 3 over 2. Okay, so what's the optimum price in the second market? Yeah, 2. What's that? 5 over 2. So, you know, it's a lot easier than doing a load of calculus, right? once you know the trick. So price charge in each market, we've done that. Monopoly profit level, well, you just plug in, you know, see the solution. Oh, it's out of focus. What's going on? Oh, there we go. So it's a property of the solution because this is halfway between these things. So the two brackets are always going to be the same. So this bracket is 3 over 2 minus 1 is a half. This bracket is 2 minus 3 over 2, which is a half. Okay, so pi 1 is equal to a quarter. Pi 2 is equal to... So this is 1 minus 5 over 2 minus 1, which is 3 over 2. This is 4 minus 5 over 2, which is 3 over 2. Okay, so it's 9 over 4. Put this right. Okay, so total profits of the sum of the two, right, is 10 over 4, which is 5 over 2. Suppose the markets 1 and 2 are now open, all consumers are free to trade, so there's no price discrimination, monopolist has to charge a uniform price. What's that profit maximising price going to be? Well, what's the demand curve for monopolist faces without price discrimination? Do you mean average? Or the sum. Something like the same thing. So it's the sum of the two. So total quantity is going to be the quantity you sell to the first type plus the quantity you sell to the second type. Okay, so 6 minus P.
Well, the profit maximising output with what costs?
No, we didn't because we've got P1
Oh,
minus.
P minus 1 with
my
marginal
bad.
cost. Okay, so if you're selling to both types of consumers at the price of P, the low type have demand 2 minus P, the high type, the high type have demand 4 minus P. In total, the demand is 6 minus 2P. Okay, so without price discrimination, demand is 6 minus 2P. So profits then are price minus marginal cost times quantity. Okay, without any calculus, what's the optimal price now? This one's a bit more tricky. Take a second.
2.
Yeah. So here, P is 3 is a 0, 2 times 3 is 6. P is 1 is a 0, so it's halfway between 1 and 3, which is 2. And in this case, profit is going to be 2 minus 1 here, which is 1, 6 minus 4 here, which is 2. So 1 times 2, which is equal to 2. So with price discrimination, we get 5 over 2. Without, they get 2. So they're getting another half of a unit of profit by being able to price discriminate. Okay, that's easy. Okay. So there's some monopolists selling in 2 markets. Let me see, yeah. No arbitrage. You've got demand curves in both markets. Total quantity. But now cost is a function of total quantity. Okay, and they're trying to confuse you a bit by giving you inverse demand curves rather than demand curves. So you can't add up inverse demand curves. It doesn't make sense to add up inverse demand curves. Okay, so you have to be a bit careful. So without price discrimination, what's the monopolist problem? Well, profit from selling in the first market, let's just write this down. So P1 was equal to 100 minus Q1 over 2. P2 was equal to 100 minus 2. Okay, so now, because the firm's costs are increasing in total quantity, this is kind of giving a link between the 2 markets. Okay, there's marginal costs aren't constant. So if they produce a lot in one market, it's making it more expensive to produce in the other market. So we can't treat it as 2 separate optimization problems anymore. We have to write down profits for selling in both markets together. Okay, so what a profit's going to be? Well, it's price times quantity in the first market.
Can you lower the thing on, please?
Is it worth rearranging the equations first to get it to in terms of Q's? So the standard markers.
Later on, when I presume later on it'll ask for profits without price discrimination, then you want to do that. But for now, it's easier to do it this way. And then, so this is revenue from the first market, revenue from the second market. Now we need total cost, which is Q squared, okay, which is Q1 plus Q2 squared. Okay, so now this is a standard problem. We do actually have to do some differentiation now. So we're going to have two first order conditions, one for Q1 and one for Q2. Here we go, dQ1. So this one, let's multiply out with brackets implicitly. So this is going to give us, this is Q1 times 100 minus Q1 squared over 2. So the derivative of that is going to be 100 minus Q1. We're only differentiating with respect to Q1, so we can ignore this term, unlike what I did earlier. And then we just have the derivative here, okay, which is going to be minus 2 times Q1 plus Q2. So that's the first order condition for selling in the first market. We have a similar one for the second market. So now it's going to be 100 minus 2 Q2 minus 2 times Q1 plus Q2. What might we do next? Well, there are two things you could do. Okay? You could either solve each of these individually, solve this one for Q1 in terms of Q2 and then plug in. Okay, that's probably the slow way to do it. A slightly faster way to do it is similar to what we were doing with Corno. Okay, with Corno we always just added up the equations and that always worked. Here we can't just add up because we'd end up with Q1 plus 2 times Q2. But if we do 2 times this equation plus 1 times this equation, we'll get something nice. Okay, so doing 2 times the first equation plus 1 times the second, we get 300 minus 2Q minus, so we get 4Q from here, 2Q from here, minus 6Q. Does that make sense? So we get 2 times 100 plus 100, which is 300. We get 2 times Q1 plus 2 times Q2, which is 2 times Q. We get 4 times Q, this is capital Q, so we get 4 times capital Q plus 2 times capital Q, which is 6 times capital Q. Okay, so 8Q is equal to 300, so Q is equal to 300 over 8. Okay, and then knowing that, we can then just plug in. Okay, so this split is 300 over 8. So 2 times it is 300 over 4. So Q1 is 100 minus 300 over 4, which is 400 minus 300 over 4, which is 100 over 4. Okay, and Q2 is equal to what's confusing? You can ask me. I'm not so scary.
No, it's a dumb question.
No, we're no dumb questions. I'm skipping lots of steps, so I can go slow. This is 300 over 8, you think? Or was it 2 at the top?
Yeah, 100 over 8, because it's just half again of what Q was. Q1 was.
Oh, Q2. Yeah, yeah, of course. Yes. Yeah. Okay. I thought you were telling me I got Q1 right. Okay. Yeah. Yeah. Let me go a bit slower so that people understand.
Oh, this is.
You're proving
So let's look at the second first order condition. And go a bit slower.
So maybe this is 1.
So, just going a bit slower. This is the second first order condition. All we've done is replace Q1 plus Q2 with capital Q. Okay, capital Q, we know what it is. We know it's 300 over 8. So just plugging in that value, we know that naught is 100 minus 2Q2 minus 300 over 4. So 2Q2 is equal to 100 minus 300 over 4, okay, which is equal to 100 over 4. So Q2 is equal to 100 over 8. Maybe you can see immediately, you can't see. Are you happy now? You sure? Okay, is everyone else happy? Yeah. So we have the two quantities. What else does it want us to do? Calculate the profit level. So this is just a matter of plugging in. We know what Q1 and Q2 is. We just plug in back into profits. So profits, you see. So just plugging in into the expression for profits, we get 100 over 4 times 100 minus Q1 over 2. Where was Q1? Q1 is this one. So 100 minus 100 over 8. That's Q2, which is 100 over 8 times 100 minus 100 over 8 minus Q squared. So Q was 300 over 8. So Q squared is a big number. 90000 over 64. And then you've just got to simplify this. So 100 you can think of that as 800 over 8. Yeah. So 800 over 8 minus 100 over 8 is 700 over 8. So this is 100 times 700, which is 70000, divided by 4 times 8, which is 32. The next term, well, 100, again, it's the same thing, isn't it? So this is, yeah, so this is 700 over 8 times 100 over 8. So 70, 1, 2, 3 divided by 64 this time, minus 90,000 over 64. Okay, so this is equal to 140,000 over 64. So 14 plus 7 is 21, minus 9 is 12. You can add that better than I can. Okay, that is 120,000 over 64. And you can probably, so this is like 6, what have we got, 4 zeros. 4 zeros over 32, so 16, you can carry on going. Yeah, okay. Whatever it is. Yeah, okay. You carry on going. Profit's the same thing. Suppose now that a new management assumed control of the firm. The young CEO decides to decompose the monopoly plant into 2 plants. Well, plant 1 sells in market 1 only, plant 2 sells in market 2 only. Okay, so what's happening is that rather than having one profit function for both markets, for Q1 and Q2, where costs are a function of both things, we're going to have 2 separate profit functions, each with quadratic costs. That's what it's asking for. So the question is saying, well, suppose we went to a new situation in which we had one firm had profits Q1 100 minus Q1 over 2 minus Q1 squared, and the other firm had profits Q2 100 minus Q2 minus Q2 squared. So intuitively, are profits with this split up firm going to be higher or lower? So total profits, so the sum of pi 1 and pi 2 here can be bigger or smaller than the pi we found before. Sorry?
It should be bigger.
Yeah.
Because
Well, it doesn't make any sense for them to split it up otherwise. But also, you've got two markets, so you can discriminate against them both. So you can extract more profit out of.
well, no, you know, you're already price discriminating here, so I don't think that's quite the story. You know, you're already choosing quantities in both markets now. So what's the difference?
You can have
You know, how are the first order conditions of this problem going to differ from the first order conditions of these two problems?
you've got rid of quantity produced by the other firm in the cost section.
Yeah, so the difference is that we've gone from having Q1 plus 2 Q2 squared to having Q1 squared plus Q2 squared. So total costs have gone down by 2 times Q1, Q2. So total costs have gone down, so total profit also increased. So that's the intuition. We won't go through the algebra. 5. So the next question was, we won't go through this either, but we'll just talk about it briefly. So here we've got two markets, one with elasticity of -2, another with elasticity of -4. Monopolist is price discriminating. Which market is going to have the higher market? Higher price, I mean. Ignore that quote for now. Which of the two markets will have the higher price?
The more inelastic.
Yeah, so the more inelastic one has the higher price. Inelastic means close to 0. You know, if it's a big negative number, that's elastic. It gets confusing because you know everything's negative. So market 1 is inelastic, market 2 is elastic. So market 1 ought to have a higher price. Okay, so can this claim be true? Well, no, it can't. Could be true. Could be true. So, what's the formula for markups? We did this in the next
Yeah.
the markup in terms of elasticity, isn't that eta minus 1 over eta, something like
I
that?
thought it was 1 over that.
1 over that. Maybe it's 1 over that. I think it's one of those two things, isn't it? It doesn't anyone have that notes? My laptop's just turning itself off.
There's something
So this either is going to be plausible. Yeah, this one looks more likely, doesn't it?
Is that 1 over?
Oh yeah, so the gross markup. Okay, so what we found that price was equal to marginal cost divided by 1 plus 1 over eta. So that's something we went through the derivation of that in the lecture. So here we had eta is -2 and eta is -4. So price in the first market is going to be marginal cost over 1 plus 1 over -2. Okay, so this is marginal cost divided by half, so it's 2 times marginal cost. Price in the second market is marginal cost divided by, what was it, 4? 1 plus 1 over -4. Okay, so, let's see. So this is 4 quarters minus 1 quarter, so 3 quarters. So this is 4 over 3 times marginal cost 2. So the claim was for the price will be 150% of the price in market 2, i.e. 50% higher. Doesn't look right, does it? 50% higher would be 6 over 3. No, it is right. 6 over 3, which is 2. Yeah, so the claim is true. So 150% of 4 over 3 is 6 over 3. 4 times 150% is 6, right? So this is 6 over 3. 6 over 3 is 2.